Okay, I will now move on to the last two boxes in this assignment number 17. Uh, if you look at the one on the top, uh, what I need to do is to basically solve these equations to get equations which are basic trigonometric equations. Okay, so let me show you what I mean, and then I'm gonna leave it at that point for you to go ahead and find the angle theta. Okay, so let's go ahead and see what I have in mind. If you look at number 39, number 39, it looks like this: tangent squared theta minus 4 times 2 cosine of theta plus 1. Now, look, this doesn't give you directly cosine of theta or tangent of theta or sine of theta, but you can actually get them by, for example, if you look at this, you can write it as tangent theta plus 2 times tangent of theta minus 2 times 2 cosine of theta plus 1 equal to 0. Okay, these are both equal to 0. Okay, so what does that mean? From algebra, we know that either tangent of theta plus 2 must be 0, or tangent of theta minus 2 must be 0, or 2 cosine of theta plus 1 must be 0. That means tangent of theta must be minus 2, or tangent of theta equal to 2, or cosine of theta equal to minus 1. Minus 1 half. So these are basic trig identities, and you know how to solve them. It's a lot of work. Basically, you have to do 3 separate problems, and since apparently you want all of them, perhaps you have to add the multiple of multiple of period in it. Just remember, when after you find this and you get a theta, you add to it multiple of the period. The period of tangent of theta is pi k. When you solve this, and obviously these you have to do it with a calculator because I don't know which angle has tangent of theta equal to 2. Once you get a theta, you add multiple of the period. And of course here, you'll get two solutions. You get theta equal to and theta equal to. Let me write it like that. You get two values of theta. That's what I meant. Two values of theta. So what you do is you add multiple of period of cosine, which is 2 pi k, and 2 pi k. Okay, so please bring it up in the class if you have any issues, and we we're gonna work it out. Okay. Uh, let's do another one, number 40. Number 40, which goes like this: tangent of theta minus 2 times 16 sine squared theta minus 1 equal to 0. So I'm going to write it like that: tangent of theta minus 2 times 4 sine theta plus 1 times 4 sine theta minus 1 equal to 0. So I get three things. Tangent of theta equal to 2, sine of theta equal to minus 1 over 4, and sine of theta equal to plus 1 over 4. These are three separate problems. You do that patiently, like we did it in the box 1, and then add multiples of the period to it. In this case, the period of tangent is pi, so you add plus pi k to it. In this case, you find, using calculator, obviously, these are all using calculator, you find two values of theta and add multiple of 2 pi to it. So plus 2 pi k. Same thing here. You get two values of theta, add 2 pi k to it. It is important for you to make sure that the stuff in box 1 or some of the stuff in box 2 are perfectly clear to you. There is no sense in doing the problems that we are just talking about if you cannot get the top box done. Okay, let's do another one, number 41. And it goes like this: 4 cosine squared theta minus 4 cosine of theta plus 1 equal to 0. Okay, I hope that you realize that this is the same as 2 cosine of theta minus 1 squared equal to 0. Or factor it, you're going to get 2 cos theta minus 1 and 2 cos theta minus 1. And therefore, 2 cos theta minus 1 equal to 0 and cos theta equal to 1/2. And just do it like the first box. And I want to remind you, when you do this problem, you'll get two values of theta, theta 1 and theta 2, two values of theta, and then you add 2 yk to it, and you're good. Let's do number 42. 42. So you have 2 sine squared theta minus sine theta minus 1 equal to 0. Let me remind you that this is the kind of thing that you use in algebra class. 2x squared minus x minus 1 equal to 0, right? If you don't know how to factor this thing, it is hopeless. You can also use the formula for quadratic, but this is simple enough. We can factor it by inspection. So it's going to be 2 sine theta. We may be able to do it, by the way. And then you put a 1 and a 1 here. You fool around with the signs, algebraic signs, so that you get a minus 1 over there. So obviously it's going to be like this. If you foil this thing, if you foil this, you're going to get exactly what's up there. Okay, so we have basically 2 sine theta plus 1 equal to 0, or sine theta minus 1 equal to 0. This gives sine of theta equal to minus 1/2, and this gives sine of theta equal to 1. Now, you know how to handle these problems. Excuse me. So you do it separately and then add multiple of 2 pi, multiple the period to it. Okay, the last one is a word problem. Well, let me see if I can get this thing worked out. Where is this? Okay, this is a problem from physics, and it says, look, if you have a an environment, for example, air and water, and a ray of light, say sunshine or whatever, is is coming down to the surface of the water, then it because the speed of light is going to change. We don't know that. This ray is going to get bent further by an angle. So it comes in at an angle theta 1 incident angle, and then if this is called the refracted angle is theta 2. Okay, and the rule is right here: sine theta sine theta 1 over sine theta 2 equal to v1 over v2. Now this v1 and v2 is let me see. This is called the index of refraction. All right. So what are we told here? If the ray, suppose that the incidence angle is 70 degrees, so theta 1 is 70 degrees. What is the refracted angle? So let me go ahead to my Word page right there. I'm going to move this out of the way so that we can see what we're doing. Okay, so we have sine of theta 1 over sine of theta 2 for the water-air interface. Well, this is equal to v1 over v2. Is that right? Let me see for a second. v1 over v2, and you are told that for a water being the medium down here, that refraction index is 1.33. 1.33, and we know that this is 70 degrees. Okay, so we have sine of theta 2 equal to sine of 70 degrees divided by 1.33, or theta 2 equal to sine inverse of this thing. You can put these things separately in your calculator, or you can do it all at once. 1.33. One thing is for sure, the angle that I got out of this, if I put it in my calculator, better be less than 70 degrees. If I get anything bigger than 70 degrees, obviously I made an error somewhere, or this data may not be right. Okay, so let's go ahead to our calculator. I think this is my calculator. Yeah, there we are. I'm going to clear everything, and I'm going to change the mode of my angle to degree. Okay, let's get rid of this. Good. So we have a second function. Second function, sine inverse of sine of 70 degrees. We already changed, remember, we changed the mode, divided by 1.33, and this angle better be less than 70 degrees, by the way. Yeah, 44.9. Almost 45 degrees. Okay, so that refracted ray of light is going to go down at 45 degrees with the vertical line. Okay, that does it. We solved all these problems.